Hi everyone, have you ever wondered what will happen if you drink seawater? Well, today we're gonna answer this very question. In a typical adult male, 60% of body weight is composed of water. For example, if a man weighs about 70 kg, water weighs approximately 42 kg. In fact, the total body water is divided into two major compartments. 40% in the intracellular compartment. That means in the cells, and 20% in the extracellular compartment. The extracellular compartment itself is separated into two sections, 15% in the interstitial compartment and only 5% in the blood. To answer our question, first we need to understand the physics of water movement between two media. Example, if we take two different adjacent media with the same volume of water, but with different concentration of sodium ions, then we separate these two media with a fully permeable membrane. That means sodium ions and water can easily and passively diffuse between these two media. After a while, we should notice that the sodium ions passed from the most concentrated medium to the least concentrated medium until the equilibrium of the two concentrations. This law is universal and valid for all the different liquid and gases without exceptions. If you ever wonder why this phenomenon happens, it's because in the universe each particle moves consistently, and that's one of the laws of thermodynamics. In the second case scenario, we replace the fully permeable membrane with a semi-permeable membrane. What will happen then? The sodium ions create a difference in pressure between the two media, which forces the water to move from the hypotonic medium to the hypertonic medium. We can use this formula to calculate the difference in pressure. We can now define the law of osmosis, where sodium ions or other particles are called active particles when they don't cross the semi-permeable membrane, and thus create the osmotic difference calculated in osmoles. Cell membrane has a sort of semi-permeable membrane, so there is a permanent movement of water between the intracellular and the extracellular medium. For example, red blood cells as shown below. In the body, active particles are sodium, potassium, urea, and glucose, and the osmolarity is calculated by this formula. It's about 300 milliosmol per liter. So what will happen if you drink seawater? First of all, you should know that seawater is very rich in salts, especially sodium, and has an osmolarity between 1000 and 1001 milliosmol per liter. That's 3 times the osmolarity of plasma. The salt compounds of seawater are active particles. So when you drink seawater, the plasma osmolarity increases, creating a hypernatremia. According to osmosis law, this condition forces the water to move from the cells to the extracellular medium. The end result is a dehydration of the cells and a hyperhydration of the extracellular compound. Symptoms of dehydration include intense thirst, mild fever, drowsiness, mental confusion, and coma in extreme cases. On the other hand, hyperhydration symptoms include a rise in blood pressure, headaches, and an abundant urine. In the end, let's say you are on an island and you are thirsty, but you don't have anything to drink. What will happen if you drink seawater? Science says you will end up aggravating your initial dehydration. You will suffer until you die. Just joking. Don't ever think of drinking seawater. Thanks everybody for watching, and make sure to subscribe. And if you have any question, leave a comment in the comment section below. You can also find me on Steemit, Library, YouTube, and Discord. Your kind support will be greatly appreciated. Thank you again, and see you in the next video.